So ray optics. Just 1 second, I'm starting. Okay. So ray optics. See some introduction of ray optics.
Sir, chapter number 9 of NCERT.
Chapter number 9 of NCERT. So the unit is optics. Optics is the study of light. Optics is the study of light. You can divide optics into two parts. One is wave optics. In wave optics, we consider light as a wave. Another is ray optics, also known as geometrical optics. In ray optics or in geometrical optics, we consider light as a ray, as a geometrical object. In wave optics, we have certain topics like Heinz principle. Then we have interference. Then we have diffraction. While in ray optics, we have, see, reflection is not a part of syllabus now. We'll do just some basic things on reflection. Then you have, there's one more term, which is polarization. Then we have Doppler's effect. Doppler's effect is also not the part of syllabus now. Then we have refraction. We have dispersion. And we have optical instruments. These are the topics in ray optics or geometrical optics. So first of all, we'll do ray optics, then we'll do geometrical optics. See, in ray optics, the ray optics is based on a very basic principle of light, which is known as rectilinear propagation of light. Rectilinear propagation of light. Rectilinear propagation of light means light travels in a straight line. This simply means that light rays travel in a straight line. Light travels in a straight line. This is rectilinear propagation of light. That light rays always travels in a straight line. This is rectilinear propagation. Whole of ray optics is based on this simple principle, rectilinear propagation. So if light travels in a straight line, so this light rays will follow all properties of the straight line. Properties of straight line, like if you have two parallel lines, then they will meet at infinity. If you put a transversal, then alternate angles are equal, corresponding angles are equal. All these properties that you have studied for a straight line are also valid for light rays. This is known as rectilinear propagation of light. So this is one principle on which the whole ray optics is valid. So basic principles that we will study in this section are valid for all topics of ray optics: reflection, refraction, dispersion, optical instruments. After rectilinear propagation of light, there is one principle which is known as principle of reversibility. This is principle of reversibility. Principle of reversibility says, like, if light ray is traveling in this direction and somehow if you can just reverse the direction of light rays, then the light ray will retrace its path. Like if you put a mirror here and you just reverse the direction of light, then light wave will follow the entire path. Like if a light ray is coming in this way and it strike the plate here, if you reverse the direction of light, then it will retrace its entire path. This is principle of reversibility. Light ray will retrace its entire path. This is it. Note it down. Then we see some basic concepts of reflection and then refraction.
That was the first one of optic wave.
In wave optics, first term, Heinz principle, Huygen. Heinz principle. Huygen. Have you done reflection in your class? Because reflection is not a part of syllabus now.
No, sir, we have.
No, sir.
And you also have skipped dispersion. No? This is not in syllabus now. This is also not in syllabus now. Even this are not in syllabus now.
So we did dispersion.
You did dispersion?
Yes, sir.
A bit of it.
Okay. Okay, we'll see some sort of. Okay, note it down. The whole of ray optics is based on some principle. The first one is rec- rectilinear propagation of light, which means light travels in a straight line. Have you written it? Rectilinear propagation of light.
Yes, sir.
Note it down. Principle of reversibility. Okay, the next topic is the concept of object and image. See, in ray optics, object means the source of light. Object is a source of light. That's an object. It's always the source of light. That's an object. So that source could be luminous or non-luminous. It doesn't matter whether it is luminous or non-luminous. It's a source of light. That light is coming from the object. Like for you, a candle is a source of light if it is an object. Also, a pen is a source of light. This is a luminous source and this is a non-luminous source, but both are sources of light, both candle and pen. Now, the object, you can divide your object into two categories. Your object could be real or your object could be virtual. So we have two types of object. One is real object and another is virtual object. The real object means rays diverge from a real object. If you have a real object, then rays will diverge from it. The real object, the rays will diverge from this real object. If you have a virtual object, then the rays will, see, this is your real object. The rays are diverging from this object. The rays will converge. So if you have a virtual object, that means the rays will converge. So your rays will converge on a virtual object and the rays will diverge from a real object. This is an object. Then we have another concept, that is the concept of image. See, this concept is valid for all, in all topics of ray optics, whether it's reflection, it's refraction, optical instrument, everywhere. Object is always a source of light. It could be a real object or a virtual object. Similarly, you can have an image. In optics, image means point at which rays meet or appear to meet. So point at which rays meet or appear to meet after reflection or refraction? So if after reflection or refraction, the rays meet at a point, then that point is known as real image. That's a real image. Now, if rays say they diverge and you produce this in the backward direction, then we say that your image is a virtual. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, now let's see how much you can retain. So, Mariam, what is an object in ray optics? What do you mean by object in ray optics? Mariam, we just have discussed, na? What is object in ray optics? Fatima, what is object in ray optics? So if people are not even listening, huh? Yes, Fatima. What is object? No, no, Sania. Amalia, what is object in ray optics? No. No, Mariam. Yes. Ahmed, will you tell what is an object in ray optics?
Is there anything that can be placed
Sorry?
before? So an object is something which we place before this in the lens.
So you people don't listen. Huh? I have explained like what is object. Abdullah, what is object?
Source of light.
Object is a source of light. Now we have two types of object. What are those two types of objects, Mariam? Do you remember what are those two types of objects? Object is the source of light. That's it. We have two types of object. What are they? Noor, what are the two types of objects?
So candle and pen.
No, this is an object. These are not the types of objects we have discussed.
So real and virtual.
Yeah, real and virtual. What is real object exactly, Ahmed?
You know, when the two light actually merges together, we find a real image over there.
Rays converge or rays diverge from a real object?
Converge.
Shahzada, for a real object, the rays converge or they diverge?
Yes, sir.
So they diverge.
What are the two types of objects, Shahzada? Just tell me. Object is a source of light, right? We have two types of objects. What are they?
So real and virtual.
Good. So what happens with a real object? Like, how will you define a real object? Rays converge
So
from
like it's
rays converge from a real object or they diverge from a real object?
so it converge.
No. See, we just have this is a real object. Rays diverge from a real object. They converge at a virtual object. Okay. What is image, Fatima? What do you mean by image in ray optics? Fatma, what do you mean by image in ray optics? Yes, Fatma, image. Define image in ray optics. Sania, what is image in ray optics? So you can't even recall things which you did in the last 10 minutes. Noor, what is an image?
So a point at which rays meet or appear to meet after reflection.
Or refraction, that's image. We can further divide image into two parts. Okay, note it down, then I will start my cross question. Note it down. Noted?
Yes, sir.
Yes, sir.
Okay. So these three or four points. The first one is rectilinear propagation of light, principle of reversibility, object and image. So these concepts are common in all topics of reflection, ray optics. So let's start with refraction. Reflection is not in the syllabus now. We'll start with refraction. The concept of refraction starts with the definition of refractive index. So what is refractive index? It defines the optical density of a medium. It defines optical density of a medium. Optical density of a medium is defined by this term, refractive index. Now, refractive indices are of two types. You can divide refractive index into two types. It could be absolute or it could be relative. So we have two types of refractive index. One is absolute refractive index and another is relative refractive index. Now let's see what do you mean by absolute refractive index. See, absolute refractive index is refractive index of a medium with respect to vacuum. It's refractive index of medium with respect to vacuum. Vacuum or air, that's absolute refractive index. And listen very carefully this time. Huh? And how you define it? This is ratio of speed of light in vacuum and speed of light in medium. This ratio of speed of light in vacuum to the speed of light in medium is known as absolute refractive index. This is represented by N and this is C by V. C is speed of light in vacuum. Speed of light in vacuum. And V is speed of light in medium. This is absolute refractive index. Now, after absolute refractive index, the next term is relative refractive index. RI means refractive index. Relative refractive index is refractive index of just one few examples. Like refractive index of water is 1.33. Refractive index of glass is 1.5. These are few examples of absolute refractive index. After absolute refractive index, the next is relative refractive index. The ratio of speed of light in one medium to another. Like refractive index of medium 1 with respect to medium 2 is speed of light in medium 2 it's basically in 1 2 is refractive index of medium 1 with respect to 2 is refractive index of medium 1 divided by refractive index of medium 2, which is V2 divided by V1. So N12 is its refractive index of medium 1 with respect to 2. V1 is speed of light in medium 1. V2 is speed of light in medium 2. And N1 and N2 are refractive indices of medium 1 and medium 2 now. So that is the definition of relative refractive index. For example, you can say that refractive index of water with respect to glass. So this is refractive index of water with respect to glass. So refractive index of water with respect to glass is refractive index of water divided by refractive index of glass. So that's the definition of refractive index. Okay, now tell me, what is refractive index, Sania? What does refractive index tells? Yes, Sania. What is refractive index? Fatima, what is refractive index exactly? Yes, Sani, tell me. Yes, Sani, I'm listening. What is refractive index? Fatima, what is refractive index?
The bending of ray of light when it
No.
passes through one medium to the other.
I'm not asking about refraction. I'm asking about refractive index. I'm asking only those things that I have discussed in the last 10 minutes, nothing else. Yes, Fatima.
Absolute refractive index and
And yes, the next is,
relative.
these are the types of refractive indices. Huh? So what does refractive index exactly tells? Ahmed,
Yes, sir.
what does refractive index tells?
It tells us the ratio of speed of light in vacuum and speed of light in medium.
Mm, which refractive index is this? Speed of light in vacuum by speed of light in medium? Absolute or relative?
Absolute.
Absolute. And how you, okay. And Shahzada, how will you define relative refractive index? Yes, Shahzada, how will you define relative refractive index? Yes, Sani. Yes, Mariam, can you tell me what is relative refractive index exactly? I'm asking only those things that I just have discussed in the last 10 minutes, nothing else. So, okay, just note it down. See, try to concentrate when I'm teaching. Right, Mariam? That's not relative, that's absolute. Yes, can I scroll it?
Yes, sir.
Yes, Shahzada, noted.
Yes, sir.
Okay, so we can relate this refractive index to wavelength also. Does anyone remember any relation between speed of light and the wavelength of light? Yes. Does anyone remember any relation between speed of light and wavelength of light? See, this is the relation. C is equal to nu lambda. C is speed of light. This is frequency. And that is wavelength. Now see, the definition of refractive index is the speed of light in vacuum to the speed of light in medium. You can even write this as this is no, that's frequency. Yes, you can write that is time period. C by nu, or you can write this as wavelength of light in vacuum divided by the wavelength of light in medium. See, as speed of light changes with medium, the wavelength also changes with medium. That is the definition of refractive index. And for relative refractive index N12, you write this as N1 by N2. Then you write this as V2 by V1. You can also write this as lambda 2 by lambda 1. Wavelength in medium 2 divided by wavelength in medium. So this is how you can relate refractive index with speed of light with the wavelength also. Just note it down. We'll do a few questions on it. Yes, can I scroll it further?
Sir,
Yes.
so it should be lambda 1 by lambda 2, right?
No, it's lambda 2 by lambda. It's inversely proportional.
Okay, sir.
V and lambda are directly proportional. It is V2 by V1, so it's lambda 2 by. Refractive index is inversely proportional to the speed. Noted? Can I scroll it?
Yes, sir.
So
Yes, sir.
solve this question. The first question, the very basic question. What is the speed of light in vacuum, Fatma? What's the value of speed of light in vacuum?
3 into 10 raised to 8.
3 into 10 raised power 8. So you just have to calculate speed of light in glass. Calculate speed of light in glass. In glass, the refractive index is 1.5. The refractive index of glass is 1.5. Note it down. Shazada, which relation you will use to calculate the speed of light in class? Yes, Shazada, which relation will you use to get the value speed of light in class?
Sir is not there in the meeting.
Okay, left the meeting. Mariam? Expression to calculate speed of light in class? It's a formula based thing. Okay, Noor. Okay, Abdullah. No, 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 not that one. This one. Use absolute refractive index. Huh? C by V. So you have refractive index. You have speed of light. You just need the value of V. Get the value of V now. Do it. Answers. I got just two answers from Abdullah and Noor. What about the rest? Good, Ahmed. Good, Fatma. See, the refractive index of glass is the speed of light in vacuum to the speed of light in glass. So the speed of light in glass will be the speed of light in vacuum divided by the refractive index of glass. So speed of light in vacuum is 3 into 10 raised power 8. Refractive index of glass is 1.5. So that comes out to be 2 into 10 raised to the power 8 meter per second. This is it. That's the expression for the speed of light in glass. Do another question. Also calculate wavelength of light in glass. Calculate wavelength of light in glass. Do it.
What will be the wavelength of vacuum?
Okay, you need value of wavelength in vacuum. Okay.
Yes, sir.
The wavelength of light in vacuum is, let's say, 5,000 angstrom. Okay, get the value of wavelength in glass. It's okay. Okay, Ahmed. Fine. See, the value of refractive index is, in terms of wavelength, is wavelength of light in vacuum. No, Fatma, you're making some mistake. The wavelength of light in vacuum divided by the wavelength of light in glass. You can write that wavelength of light in glass is wavelength of light in vacuum divided by the refractive. In vacuum, it's 5000. Refractive index is 1.5. So that will be 0.3. So it's 1000 by 3. Not 1000, 10,000 by 3.
Sir, sir,
Yes.
we will not convert this A0 into meter.
Sorry.
So this A power 0, right?
Yeah, that's angstrom. Na? You can
Yes, sir.
just you can keep the calculations in angstrom only.
Okay.
If you want, you can multiply it with 10 raised power minus 10, then it will be, and then it will convert into meter. Otherwise, you can keep it in angstrom only.
Okay.
Yes, is it clear, Amalia? Is it clear?
Yes, sir.
Yes.
Okay, just note it down. I will stop here. Thursday we'll start with refraction. Huh? So that was about refractive index only. From Thursday we'll start with the Snell's law and other things.
Yes.
Okay, sir.
Thank you. Allah Hafiz.
Thank you, sir.
Sir.